we notice that every year millions of public procurement notices are published across European Union, and they described how the information, how the who want to buy what from who and how much this kind of procurement information in the XML format. And finally, they are translated into notch graph to describe this kind of information in a linked data way. And the problem is that what will happen if the generated notch graph is inconsistent. For example, like in this example, we see that we saw the organization is a winner in the original file, but finally in the notch graph, it becomes a reviewer, so it is a significantly problem, and the downstream application cannot use it. It will cause this an error. This is a very serious problem, and the risk is real since the translation process involves multiple steps, like we show here. We can see that the original file is XML and our goal is a notch graph, but because the XML file is very complicated, so the expert have to, like based on the ontology and XML, they write down some rules, hundreds of rules in Excel sheet, and based on the Excel sheet, they write down hundreds of rules for the finally execution of the notch graph generation. And during these manual steps involved in it, we can imagine how easily the inconsistencies are introduced during this process. And what we want to do, we want to detect the inconsistency. But the problem is that in our country methodology, the inconsistency can only be detected after the final notch graph is generated. After we already have the final data, we write down some constraint, like people can only have exactly one student ID, this kind of constraint. We validate and we saw the error, we back to fix it. But we don't want it, so the company who responsible for construct such notch graph, they hope our team from Leuven can help them to design a unified approach for detect this inconsistency before the notch graph is constructed. So what we want is that we want to have a unified data profile for the a lot of different data formats. For example, if they are in different language, Spanish, Dutch, but we want experts can easily understand it. So what is the easiest way we translate it into English? So this is what we want to do, and all translated into English, and we write down a compile script to compare the different to see whether they are aligned with each other. So we assume that SHACL, a W3C recommendation language for validating notch graph, is a very good language for us to use as a unified data profile. So what our methodology is, first, because we want to translate every data format involved in the process into a unified, into SHACL. So we need the translators here. So we consider that if the translators are already here, already exist, then we directly reuse them. But if it haven't been developed and designed, then we design and develop it. And after have all SHACL shapes, we continue to detect the consistency and generate the validation report. So for the for one artifact involved in the process, we notice that the translator haven't been here. Thus, we formalize the translation process and finally generate SHACL shapes. And this kind of idea actually can apply on any other domains that relevant to notch graph. For example, like the adhesive selector. So once you need to construct notch graph, once you need to ensure the data quality, you can use this way. And after you have all SHACL shapes, then we designed 3 modules for detect the inconsistency. Then we just fit the SHACL shapes into and get the final validation report. We can see it is in JSON format. So we will see, for example, there are 3 artifacts, and we found that, okay, the winner appeared in 2 artifacts, but not appeared in another, in the 3rd artifact. So we know that there must be some problem happened. For example, here the reviewer is wrong. So based on this, we can easily see the inconsistency and know which rule has a problem, which artifact has a problem. And by applying our methodology, we can easily detect the inconsistency before the knowledge graph is constructed. And finally, benefit from our validator. You can easily see that the reviewer is wrong, then people can fix it before the data is generated. Now we can have a reliable knowledge graph. Thank you.